ground fault occurs when an electrical current escapes its intended path and flows through the ground. This can happen due to damaged insulation, loose connections, or moisture in the circuit. Ground fault circuit interrupters, or GFCIs, are designed to detect these faults and trip to prevent electric shock. When an inductive load, such as a computer or uninterruptible power supply, known as a UPS, is turned on, it draws a large surge of current that can cause the GFCI to trip. This is because the GFCI may perceive the inrush current as a ground fault. GFCIs have different sensitivity levels. A highly sensitive GFCI may trip more easily, even with small amounts of current leakage. To identify the ground fault, firstly, check the circuit for any damage to the wiring, loose connections, or moisture. Repair or replace any faulty component. Secondly, install a dedicated circuit for the computer and UPS to avoid sharing the circuit with other power-hungry devices. Thirdly, replace the existing GFCI with one that has a lower sensitivity level. This may help prevent nuisance tripping due to inrush current. Fourthly, install a GFCI outlet adapter into the non-GFCI outlet for the computer. This adapter will provide GFCI protection without causing nuisance tripping. If the problem persists or if you're unsure of the cause, it's recommended to contact a qualified electrician for further troubleshooting and repair. The location of the GFCI outlet is important. It should be accessible but not exposed to moisture. Regularly test GFCIs to ensure they are functioning properly. Consider using surge protectors to protect sensitive equipment from power surges. A deeper dive into ground faults reveals they are often insidious, developing slowly over time as insulation degrades or connections loosen. Visual inspection is key. Look for frayed wires, discolored outlets, or signs of water intrusion. Remember that even seemingly minor issues can escalate into significant hazards, so prompt attention is crucial. The inrush current phenomenon is particularly relevant to devices with large transformers or capacitors, such as computers, UPS units, and some types of lighting. When these devices are initially powered on, they demand a brief but substantial surge of current to charge their internal components. This surge can easily exceed the GFCI's trip threshold, leading to a nuisance trip. Understanding the device's power requirements and the GFCI's sensitivity rating is crucial for effective troubleshooting. GFCI sensitivity is a critical factor often overlooked. GFCIs are designed to trip at a specific current leakage level, typically around 5 milliamps. However, some GFCIs are more sensitive than others, and even slight variations in current can trigger a trip. Factors like the age of the GFCI, its manufacturing quality, and even environmental conditions can influence its sensitivity. In situations where nuisance tripping is a persistent problem, consider using a GFCI with a slightly higher trip threshold, but always ensure it meets the required safety standards. When attempting to identify ground faults, remember that it's not always a single, obvious problem. Sometimes, multiple small issues can combine to create a cumulative ground fault that triggers the GFCI. Use a systematic approach, starting with the most likely sources of trouble and working your way through the circuit. A multimeter with ground fault detection capabilities can be invaluable for pinpointing the location of the fault. Installing a dedicated circuit for sensitive electronic equipment can significantly reduce the likelihood of nuisance tripping. A dedicated circuit ensures that the computer and UPS are not sharing the circuit with other devices that may draw large amounts of current or generate electrical noise. This isolation can help stabilize the power supply and prevent false triggers. When choosing a less sensitive GFCI, be careful to select one that still provides adequate protection against electric shock. Consult with a qualified electrician to determine the appropriate sensitivity level for your specific application. Remember that GFCIs are designed to save lives, so compromising safety for convenience is never a good idea. Using a GFCI outlet adapter can be a convenient solution for protecting individual devices without replacing the entire outlet. These adapters plug into standard outlets and provide GFCI protection for the connected device. They are particularly useful in situations where it's not practical to replace the existing GFCI outlet. Regular testing of GFCIs is essential to ensure they are functioning properly. Most GFCIs have a test button that simulates a ground fault and causes the GFCI to trip. Test your GFCIs monthly to verify that they are working correctly. If a GFCI fails to trip when tested, it should be replaced immediately. Surge protectors are an important component of any electrical safety system, especially for sensitive electronic equipment. Surge protectors help to protect against power surges and spikes that can damage or destroy electronic devices. Consider using surge protectors in conjunction with GFCIs to provide comprehensive protection against electrical hazards. Additional items to know that electrical codes vary by jurisdiction, so always consult with a qualified electrician to ensure that your wiring meets local requirements. Improper wiring can create safety hazards and may not be covered by insurance. Also, GFCIs are not a substitute for proper grounding. A properly grounded electrical system is essential for preventing electrical shock and ensuring the safe operation of electrical equipment. Be aware that some electronic devices can generate harmonic distortion, which can interfere with the operation of GFCIs. If you suspect that harmonic distortion is causing nuisance tripping, consider using a line filter to reduce the distortion. Finally, remember that electricity can be dangerous, so always take precautions when working with electrical systems. If you are not comfortable working with electricity, contact a qualified electrician for assistance. Now let's cover electrical safety tips. Always turn off the power at the breaker before working on any electrical circuit. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. Never work on electrical circuits in wet or damp conditions. Be aware of the location of overhead power lines and maintain a safe distance. Never overload electrical circuits or extension cords. Inspect electrical cords and plugs regularly for damage. Replace any damaged cords or plugs immediately. Use ground fault circuit interrupters in areas where water is present, such as bathrooms, kitchens, and outdoor areas. Test GFCIs monthly to ensure they are functioning properly. Install smoke detectors and carbon monoxide detectors in your home and test them regularly. Develop an emergency plan in case of an electrical fire or other electrical emergency. If you experience an electrical shock, seek medical attention immediately. If you smell burning plastic or see sparks, turn off the power at the breaker and call a qualified electrician. Never attempt to repair electrical equipment unless you are qualified to do so. If you have any questions or concerns about electrical safety, contact a qualified electrician for assistance. Grounding is a critical aspect of electrical safety. It provides a path for fault current to flow back to the source, allowing the circuit breaker to trip and to energize the circuit. A properly grounded electrical system helps to prevent electrical shock and reduce the risk of fire. The grounding system consists of a grounding electrode, such as a ground rod or water pipe, and a grounding conductor that connects the electrical system to the grounding electrode. The grounding conductor must be properly sized to carry the fault current. All metal enclosures and equipment must be bonded to the grounding system. Bonding ensures that all metal parts are at the same potential, reducing the risk of electrical shock. The grounding system should be inspected regularly to ensure that it is in good condition. Loose or corroded connections can compromise the effectiveness of the grounding system. If you have any questions or concerns about grounding, contact a qualified electrician for assistance. Understanding electrical codes is essential for ensuring the safety of electrical installations. Electrical codes are developed by organizations such as the National Fire Protection Association and the International Code Council. These codes provide minimum safety standards for electrical wiring and equipment. Electrical codes are updated regularly to reflect new technologies and best practices. It is important to stay up to date on the latest electrical codes to ensure that your electrical installations are safe and compliant. Electrical codes vary by jurisdiction, so always consult with a qualified electrician to determine the applicable codes in your area. Improper wiring can create safety hazards and may not be covered by insurance. If you have any questions or concerns about electrical codes, contact a qualified electrician for assistance. Electrical panels are the central distribution point for electricity in a building. They contain circuit breakers that protect individual circuits from overcurrent. Electrical panels should be properly labeled to indicate the circuits they serve. Electrical panels should be accessible and kept clear of obstructions. Electrical panels should be inspected regularly for signs of damage or corrosion. Loose or corroded connections can cause overheating and create a fire hazard. If you have any questions or concerns about electrical panels, contact a qualified electrician for assistance. Circuit breakers are designed to protect electrical circuits from overcurrent. They trip when the current exceeds the rating of the circuit breaker. Circuit breakers should be properly sized for the circuits they serve. Circuit breakers should be tested regularly to ensure that they are functioning properly. A circuit breaker that fails to trip when tested should be replaced immediately. If you have any questions or concerns about circuit breakers, contact a qualified electrician for assistance. Wiring methods refer to the types of wiring used in electrical installations. Common wiring methods include non-metallic sheath cable, armored cable, and conduit. The choice of wiring method depends on the application and the local electrical codes. Non-metallic sheath cable is commonly used for residential wiring. Armored cable is used in areas where the wiring is subject to physical damage. Conduit is used for underground wiring and in areas where the wiring needs to be protected from moisture. If you have any questions or concerns about wiring methods, contact a qualified electrician for assistance. Outlets and switches are the points where electrical devices are connected to the electrical system. Outlets and switches should be properly installed and grounded. Outlets and switches should be rated for the voltage and current they will carry. Outlets and switches should be inspected regularly for signs of damage or wear. If you have any questions or concerns about outlets and switches, contact a qualified electrician for assistance. Lighting is an important aspect of electrical design. Proper lighting can improve visibility, enhance safety, and create a comfortable environment. Lighting should be energy efficient to reduce energy consumption and costs. Lighting should be controlled by switches or dimmers to allow for flexibility. Lighting should be properly installed and maintained to ensure safe operation. If you have any questions or concerns about lighting, contact a qualified electrician for assistance. Motors are used in a variety of electrical applications. Motors should be properly sized for the load they will drive. Motors should be protected by overload relays to prevent damage from overcurrent. Motors should be properly maintained to ensure reliable operation. If you have any questions or concerns about motors, contact a qualified electrician for assistance. Transformers are used to change the voltage of electrical power. Transformers should be properly sized for the load they will serve. Transformers should be protected by fuses or circuit breakers to prevent damage from overcurrent. Transformers should be properly maintained to ensure reliable operation. If you have any questions or concerns about transformers, contact a qualified electrician for assistance. Control systems are used to automate and control electrical equipment. Control systems can range from simple on-off switches to complex programmable logic controllers. Control systems should be designed and installed by qualified personnel. Control systems should be properly maintained to ensure reliable operation. If you have any questions or concerns about control systems, contact a qualified electrician for assistance. Power quality refers to the characteristics of electrical power that affect the performance of electrical equipment. Poor power quality can cause equipment to malfunction or fail prematurely. Power quality problems include voltage sags, voltage swells, harmonics, and transient voltages. Power quality can be improved by using power conditioning equipment such as surge suppressors, line filters, and voltage regulators. If you have any questions or concerns about power quality, contact a qualified electrician for assistance. Here are some additional troubleshooting steps. First, isolate the computer and UPS. Disconnect the computer and UPS from the outlet and test the GFCI. If the GFCI still trips, the problem is likely in the wiring or the GFCI itself. Second, test the computer and UPS on a different circuit. Plug the computer and UPS into a different GFCI protected outlet. If the GFCI does not trip, the problem is likely with the original circuit. Third, check the GFCI wiring. Make sure the GFCI is wired correctly. The line and load wires should be connected to the correct terminals. Fourth, check the ground connection. Make sure the ground wire is properly connected to the outlet and the electrical panel. Fifth, use a GFCI tester. A GFCI tester can be used to simulate a ground fault and test the GFCI. Sixth, replace the GFCI. If all other troubleshooting steps fail, replace the GFCI. Seventh, consult with an electrician. If you are unable to resolve the problem, consult with a qualified electrician. Electrical formulas are essential for understanding and calculating electrical circuits. Ohm's law states that voltage equals current times resistance, or volts equals amps times ohms. Power equals voltage times current, or watts equals volts times amps. These formulas can be used to calculate voltage, current, resistance, and power in electrical circuits. If you have any questions or concerns about electrical formulas, contact a qualified electrician for assistance. Now let's consider the National Electrical Code, or NEC. The NEC is a set of standards for the safe installation of electrical wiring and equipment in the United States. The NEC is updated every 3 years and is adopted by most states and local jurisdictions. The NEC covers a wide range of topics, including wiring methods, grounding, overcurrent protection, and equipment installation. Following the NEC is essential for ensuring the safety of electrical installations. If you have any questions or concerns about the NEC, consult with a qualified electrician. Specific NEC articles might be helpful. For example, NEC Article 210.8 covers ground fault circuit interrupter protection for personnel. NEC Article 250 covers grounding and bonding. NEC Article 300 covers wiring methods. NEC Table 310.15b16 provides ampacities of insulated conductors. These are just a few examples of the many NEC articles that are relevant to electrical installations. When working with electrical systems, it's crucial to understand the basic principles of electricity. Electricity is the flow of electrons through a conductor. Voltage is the electrical potential difference between 2 points. Current is the rate of flow of electrons. Resistance is the opposition to the flow of electrons. Understanding these basic principles is essential for troubleshooting electrical problems and designing safe electrical systems. Finally, consider the specific equipment involved. Review the specifications for the computer, UPS, and walkie-talkie chargers. Check their power consumption, inrush current, and grounding requirements. This information can help you identify potential compatibility issues with the GFCI.